Hi. Hello.
Hello. Hear you.
How's your Sunday?
Yeah, so far so good.
Great.
Yeah, just reading reading the paper and also like the textbook.
Oh, nice. Yeah. Which one are you reading? Which papers are you reading today?
Like the the paper that we're going to discuss, the autoregressive energy retrieval, and then for textbook, I think it's like week. Is it week 4 or week 5? I think it's week 4.
I was reading this relevance-based language models today. I don't know if you've seen it. I'm not even sure who was mentioned in the CS410 class or 447. I'm just confused, but it was so good. It was so helpful. It like drew just a very good overview distinction between relevance-based models and language models and information retrieval. It's a good one.
Yeah, there's some overlap there.
Okay, yeah.
Which paper was that?
Relevance-based language models. I'll link it in a second.
Okay.
It was a fun one. Yeah.
Did you already finish the 447 assignment?
Yeah.
You did it before they did the release the like a little help video or whatever it was.
I think so. Yeah. I didn't. I didn't.
I think that assistance thing was just released yesterday.
Got it. Yeah, I think I finished before that. Raj, if you want to start, then feel free.
Yeah. Like, would anyone else be joining? Like, while I figure out like how to share my screen.
I'm gonna share. I'm gonna do a at here on the channels to let people know that we have this.
I always forget. I need to turn this on. Okay, you should be able to share your screen now. Try again.
No, more like settings on my end because I haven't set that up yet. Okay, yeah, I basically have to restart Chrome for that. So yeah.
Okay. I'll see you in a minute.
Like, I'll be back in a minute.
So I hope that they can actually release the next assignment earlier, so that like we have more time to do the second homework.
So the ad here is a little bit less noisy than channel.
Oh yeah, that's pretty clever. We still don't have the literature review topics, right? Still waiting for them.
Send it to 447 as well.
Oh, maybe don't do that. I think that's not a good idea.
Well, it's not a channel, it's just at here. So there's people who are
well, let's not do that next. I feel like people that we kind of advertise it and people that joined and like
we're done inviting people for the group then.
Yeah.
Or is it okay to do it without an at here or at channel?
I think without ad here it's fine, but like, yeah, people that didn't elect themselves to be pinged shouldn't be pinged probably.
Fair enough. I will remove the ad here.
Yeah, so one sec. I can just try and share my screen. Cool. Yeah, let me know if it works.
Working.
Perfect. Cool. So yeah, I think the GIF that I posted like a few days earlier when like pitching the paper is like the best summary of like what it does, in that basically you'll be able to respond to a query with like a Wikipedia article or some knowledge base entity. And the main crux of the paper is to take something that comes as a natural language query and then generate a page, like page name that you'd need to link to in the knowledge base. So in this case, it goes to history of the internet. In other cases, you might go to something like Metropolis and go into Metropolis comics and go to what's relevant rather than like just a copy paste of the text and like the exact name. And yeah, that's like the bluff of the paper. So yeah, I think this one is going to be like more relevant with like CS 410 as well, with text information systems, because a lot of it goes into like how we can retrieve documents, while going into a completely different model and into the NLP side of things. Because one of the most interesting things the paper does is that it will let you retrieve things without looking into the actual content of the documents, and instead generally looks at what is the context it's been referred in most cases. For example, if you say something like, okay, Superman saved Metropolis, and the training data would have references to like its Metropolis comics and not really the Metropolis algorithm. And later on, when there's an actual query, the actual algorithm is going to look at the context in which it's been used to link you to the page that's required. And yeah, that's the basic pitch for the paper. And going into it, I'll say like the most useful thing to start and like defining the problem space is given in like in this one diagram out here, to say that what are the main things we're trying to solve. So the first one would be, in case you have like start and end tokens defined, for example, like Superman saved Metropolis, and it says that, tell me which Metropolis we are talking about, because Wikipedia might list like 10 articles that are relevant, and to pick up like which article is actually useful given the rest of the query. So that would be one case. The second is if you're linking part of the query, which is like railway station, which is like too generic, but to identify like what exactly is relevant given other parts of the sentence. And the other part, which is handled in a different paper that is related, but we don't really cover today, would be to translate it into a different language. And that part looks pretty fascinating, but I don't think we can make it to that. But that's one class of problems. The second is to actually answer like natural language queries to say that what's the capital of Holland, and then compose the results out of that. Like one is you can just get like Netherlands and start to look further. It might not get you to like the exact answer that is needed in this case, but yeah, it actually starts taking in the right direction. Whereas something like out here, where it's like the nuclear accident and for the 3 Mile Island accident, it's super powerful in that it can directly take you to the actual page that's relevant and answering queries that users have. And finally, like the last class of problems that it has is there's something reference that's like an exact page name or an exact knowledge base entity name, and it just has to link you over to that. So out here, like Conrad Dunn or like Stripes, but making sure it goes to the right version of the page, because there might be like multiple entities, is what's being handled. So yeah, how does that sound? Like, does the problem space seem clear? And yeah, shall we dive into the next part?
Yeah, that sounds very cool. Like implicit factual knowledge thing, like that's literally how I wish Siri worked, but it doesn't.
Yeah. So one second, I'm just going to jump over to the appendix so that we take a look at the like example input data first, and then get back, because that's one of the things I personally struggled with at the start, because I wasn't quite sure like what's going in, what's coming out in the training sets, and like what's the expectations. So this ended up being pretty useful. So yeah, and then the inputs that are present are something that would just be like a really long sentence in this case. So it finally takes like a long sentence and then says that there's an entity called Metropolis, and then also links you over to like what the actual output should be. And then there are references to like other things which are being predicted. But like the key part that is relevant is like what exactly is like the input that we care about, or like what exactly is the entity and what should it be linked to. And then out of that, you get some results as to like, you have potential entries for like maybe tool in this case and a few other options. So
the training data set consists of this sentence and already labeled entities in that sentence, right? That's how it is.
yeah. So one sec, I'm just going to jump over to the example that's there. So that go for the small one so that I don't completely mess up my computer. Yeah. So yeah, basically you have this really long sentence, but you then have like an example of what needs to be present, which is like the battle of this, which should show. Oops. Yeah. I'm just going to go to this because I expected it to wrap around, but that didn't work. Yeah. So yeah, so it just takes like this as an entity that's present, and the expected output is provided in the training data set to say like, yeah, you want this thing to be identified and give the Wikipedia article ID that is actually corresponding to it.
Was that training data, it's all hand labeled, right? These are.
Like it doesn't need to be, because the neat part about it is that Wikipedia has like inline references to what was required. So you have like this really amazing pre-labeled data that you can use without any changes.
Okay, right. So Wikipedia is the training knowledge. Okay.
Like it also has a few other sources which are listed, but like Wikipedia is like the gold standard already. And they have only used the abstracts for it rather than like looking through the entire document, and are also like careful to not look at the document itself when making the predictions.
Yeah, but in a, let's say in a regular industry scenario, getting this good label data, that's gonna be a challenge, right? So, and these are okay from research perspective, but in industry, getting this kind of entity relation, really building that kind of data set would be challenging.
Like that would kind of depend upon like, suppose it's a knowledge base and it's like cross-referencing articles, and you have like a decent like internal Stack Overflow, for example, which links to this, that can serve as like one potential avenue. So it's like, it would depend on like what the existing infra is available for every industry, but that would kind of contribute to like whether this can be applied or not.
But I think what you mentioned just in the example is you need to identify the entities, right? That's an input in terms of training data.
Yeah.
So let's say if I am in my organization, my vocabulary is different, my entities are different, then somebody needs to go and either label them, or we need to come up with some automatic mechanism to do that labeling. Right?
Like that, or like you have a few other cases where it's like you have sample data that's already available, and there are a few cases where they've gone into like specific examples, like certain, like with certain data sets. But yeah, if it's not going to be like available to like all cases immediately.
So just to summarize, the main requirements are you need to have the entities already labeled in your data set, and also the corresponding answers and the linkage to the relevant page or whatever reference document is, right? That's the setup.
One sec, I'm not sure if I entirely got it. Could you repeat that?
So the setup, in order to, let's say, in order to recreate this experiment, the setup is we need a training data set that has already entities labeled in it as input sentence within the input sentences, and what is the answer or the the output that you are looking for, right? Like the example that you showed. So that's my training data essentially.
Like that is in part, like it also like in the end talks about like how it can be extended further to like other cases. So how does it perform with like, you just give it like 15 new document names without like any actual references, and like this is how it actually is. And like it's still able to perform like relatively well in answering queries. Like performance is not as good as other cases, but in like smaller scale settings, like it can perform well. But yeah, like it wouldn't be like the ideal case and like the ideal way to run it.
So would one example of this be, let's say a company has their own wiki or their own FAQ, and so then you're able to, let's say do a chat bot where somebody just asks any kind of question, and then they should be able to figure out, disambiguate the question to the exact context that they're asking.
Exactly the use case.
Okay.
And yeah, so there's like a more formal description of like the entry retrieval problem, and there are like also a few other cases. But like if that part seems like we might want to take like a couple of minutes to read this, and one section of the appendix to like just describe the problem. So if you could just open it and just read through like the experiment details to like just understand what's being done. And like it's enough to like really briefly skim it, and then we can go into like how exactly it's being done, which is like the actual meat of the paper and what's being done differently. So shall we take like 5 minutes and just give it like a really quick read? So it's not like really important, but just to know like what's being done and the problem.
Are you using version 1 or version 3? Does it matter?
One sec.
I see you're using version 1. Does it? I don't know if you bothered to.
Version 3.
Version yeah. So version 3. I mean, I'm just saying based on the URL, it looks like you're using version 1, but I don't know if it was.
Because the previous versions were like going into like how it's not yet been published. For example, like version 1 mentions that it's under review.
Oh, I
whereas one. So like it just happens like V1 at the end of it then.
I have a question. So reading this, the second section called entity retrieval, they pose the problem the same way they pose the problem as a classifier, right? You have your input X, and then you need to assign labels to it, possibly multiple labels from the set epsilon, right? And you could treat this as a document retrieval model as well, where you're retrieving documents identified by their titles on Wikipedia, but it's all the same. It doesn't matter. I think this makes a lot of sense. I don't understand, like, they're critiquing the naive approaches with regular, like, what are they called? Dense encodings and word encodings. I'm not sure I get what their critique is.
Sorry, like which part of it? Like in section 2, but I didn't get like.
Right. And their critique is like in the beginning of page 2. They say, unfortunately, the classifier approach to entity retrieval has several shortcomings. Here, yeah, could you expand on what they're saying there? I'm not sure.
Yeah, so effectively trying to like capture like more information about like interaction within like the query with like what the expected output is, and trying to capture more of the information and using that for generating what is relevant. So that is like what I took away from it. And the second part of it is also going really deep into like what is the cost of like storing this? Because compared to storing like a really large, like high dimensional vector for like the Wikipedia pages, like
Okay.
this particular data structure can be done in like around 700 megabytes, which then translates into like usage in like many more places. So maybe you can avoid using a server in some cases.
Okay. That's fine. That makes sense.
So I think the latter part is like more important, like in just like practical terms and where it can be deployed compared to like the other part, because those can still be fine-tuned. Whereas like the memory almost feels like it is like an order of magnitude difference compared to like other approaches, which would be like the main differentiating factor in my opinion.
Okay. Okay.
And what is the definition of entity? I was going through, it says, we assume you to have a collection of entities, example, Wikipedia articles. So
So
is the entity definition an article? Because, yeah.
So effectively out here, the like definition is like, so the problem space is identifying the right entry in a knowledge base. And so each entity in a knowledge base is assumed to have like a unique name and like a full passage on like what the contents are, and also have references from like other parts of the knowledge base that actually. So each entity is then like identified by like some entity ID, which would be its title, and like have some content.
Oh, okay. So let's say if we have a big database of all the Wikipedia pages, then every row will be considered as an entity, which means every page is an entity.
Yep.
And the objective is to find, given a question, find the right entity in a way.
Yep.
So, hi, this is Amar. So, this is my first session in this group. I was just patiently hearing what Raj you were explaining. Okay, so I bit late in that, so I didn't get it. So, is it like that this particular application is trying to like given a question asked in for a document, it will point you to a specific section of the document? Is that the usage, or what is the use cases basically?
So I think the main use case would be something like a chatbot, where you just ask it like a natural language query, such as the one here. So it's like, which nuclear reactor had a major accident in this time? And then from that, it takes you to the article that answers your question best. So
Okay, so basically it is a kind of, sorry, so sorry, I'm trying to understand hard. So is it a kind of thing like a researcher is trying to find relevant article for his queries, research queries, and in this kind of system will actually return him a list of articles, or within a document it will return the section or paragraph which is relevant to that query? Is that something like this?
not within a document. It would be at the higher level. Because
oh, okay. So in a repository of documents, it will actually send you the right document.
Yeah, because the main differentiating factor compared to like other approaches is that it doesn't look at the actual contents of the article itself, and instead like points you to the article from like what context it's been used in. So that is like how this paper is like different.
Okay. Okay.
So the key differentiator of this technique over traditional techniques is that you have a smaller indexing by leveraging the existing relationships between the documents via the named entities.
Yep.
Okay, and then the traditional approach is you would index across every single term right?
Yep.
That's it. Are there any other approaches that they compared and contrasted?
Like I think the like full spectrum would be something like the entire 410 course, but the main thing under that would be like how exactly would we represent that information and how do we like identify relevance. So instead of like trying to look into like which document has the words that we care about, it instead tries to generate the article name and then find the answer on the basis of that. Like
Right.
that's
Very much a
how it-
top-down approach. Like you're saying, hey, look, I know some stuff. Here's my question. What do I think is the right document that will answer my question? Or what am I talking about?
Yep, that's exactly the thing. Yeah.
Cool.
Yeah, Raj, Amit here. Another question. So, given this given this problem, the traditional approach is, let's say we have these Wikipedia pages, we could run them through any doc2vec or word2vec, some kind of we convert that entire article into a high dimensional vector, right? That's one way to, let's say, offline you can store these vectors, articles, and when you get a question, you convert it into a vector and then do some kind of similarity measure, right? To see which one is most relevant or most similar to my question. Like, that's the most basic approach you could think of. Where is the difference between this basic approach and this approach suggested? Probably a little bit.
So I think like that's pretty much like the next section. Okay. And what it does is it takes the query as an input and then tries to like generate a sequence of like words effectively, which would then match a repository article. So for example, in this case, it matches you against like Leonardo da Vinci or like whatever is relevant in that case. So it like generates it word by word and then points you like, yeah, you need to go and take a look at this document. And instead of like
the query, it generates the query. Sorry.
Sorry, not the query. It generates a document title effectively, and then like takes you there. So for example, in this case, it would just keep passing through the sentence and like just say like, hey, that's Leonardo. Let's try and see which article is relevant. And then starts to create like a mention. Then it says like, it's Leonardo da Vinci, and then done. That's the mention. And that's the article it should be linked to.
It's like a beam search it's trying to do.
Yep, it's exactly that. So that's the next section on how it does. And yeah, like the sections like 3.1 and like 3.2 are like, I think 3.1 in particular is like the most interesting section of the lot in terms of like what's being done.
Is Google doing something like this with like their query rewriting?
Query rewriting, I'm not sure, but yeah, that it could be one way in which it generates like suggested queries. Yeah, so I think that's what you mean by query rewriting.
Not suggested queries. Suggested queries is like I think it's like popular queries. I think they're doing something. I have to double check, but I think they're doing something where you write a query and they're like, well, this is what you probably mean, and then it makes more effective use of the search results.
Right. Beam search is a very common technique. It's used in like even in language translations, many places. It's just effectively, it's like given what you know in the past, what is your best probable option in the future. So given you saw Leonardo, probably what are your options? You take Da Vinci and then you keep on moving forward with that. And there are different variants of beam search. But the whole idea is, in a way, sentence generation. So, to your point, Raul, where query rewriting or query expansion, I would say, yes, this is one of the techniques which are generally used in search engines. Is you do beam search and take all the top probable sentences that you could generate out of your base query, and then fire all those in parallel.
So then this is expanding on beam search, right? Beam search is already existing. This is expanding on that.
Yeah. Beam search, I believe, from what I understood from this section, is they are using your input question to do some kind of a beam search. So your input query is broken down into pieces, and then it uses this idea of beam search to see what are the different probable articles at every stage of that sentence input query.
It's like slightly different in that part. So in this case, like it takes and like generates the sentence, like it takes the entire query as input and then starts to generate like one word at a time what could be an option. And then like the main difference is like it constrains the beam search. So for each word that's generated, it's also validated to see like, is that going to be like a valid Wikipedia article and like entry or title? And only if it is would it have like a reasonably good like score. Otherwise it's going to have like a negligible score and not really considered at all. And then you can keep considering like things along like the entire beam in order to generate like the query that you need.
I think what would be more interesting probably is in these kind of problems where you're looking into a knowledge base, the vector space is so high that even just looking and doing similarity takes a lot of time.
Yep.
So technically, if you can make that retrieval process quick in some by applying some technique, then it's a great win because it's a pain. When these query responses are expected to be in sub-seconds, like I know a system wherein it was like 100 millisecond response time or 300 millisecond response time.
Yep. Like, and one second, I'll just they also have a diagram of like the data structure involved with like how exactly it's structured. And then like it ends up being like super efficient because you only have things that are immediately required. So you can directly say that what's the result that's being generated and says like English. Okay, you have like two options. You either have language, literature, or you have like an invalid token in this particular vocabulary. And then it's really easy to like trim out like all irrelevant results and only take the beam through like valid options. So that's the interesting part that's done in this particular like paper.
Is that tree constructed ahead of time, or is it as it's doing the algorithm, it's constructing the?
Like this can be pre-constructed because like all the list of all Wikipedia articles or like all knowledge base articles is known. And so you can just generate this try and also like have it compressed. So this is the part where it's like, this is the biggest data structure that they have and like it's 600 MB. And once that's like the only thing that they actually need to like constrain the results that are coming out.
So 600 MB, is there a page that has all the metrics? Like 600 MB is how many documents versus how many?
Sorry,
tokens?
I didn't catch that. Sorry.
How many documents does 600 megabytes represent?
The whole of Wikipedia.
The whole of Wikipedia.
Yeah, entire Wikipedia.
In how many languages? Just English?
Yeah, like it only needs the titles, so that's why it ends up being a lot smaller. But like you pay the cost with like extra pointers, so it's a little bit larger than it needs to be.
So it's just storing the title of the Wikipedia pages, nothing more than that?
Yeah, it's only the titles.
Oh, that's amazing then.
So then it's like
by looking at the title.
Okay, so revisit this at a high level. Every single Wikipedia article by title has been indexed using this trie structure, and the entities that are named within the titles, and I guess the titles don't reference each other, right? The bodies reference each other.
Sorry, the what reference each other?
There's no links in the titles, right, to other articles, right? It's just
Yep.
within the bodies. So it's using the links within the bodies to create the name, the entity links. And then it's creating a tree structure or a tri-structure on that. And then the question comes in and it using that structure does a beam search to figure out which document specifically is going to be able to answer this question.
Yep. And just have like the top 3 queries based on like the probability from the beam search if we need options, or like effectively the I'm feeling lucky option and just pick the first.
Okay. And then how long were they able to have this perform, or how fast?
So one second. That's something that I'll need to check, but yeah, So I was mainly focusing on like what's the quality of the results. I'm sorry,
Sure.
I don't have the exact number like in my head right now for like what the performance of like the actual amount of time taken was, but like the like performance results where it was like pretty good compared to like the other options present. And then like there's a breakdown like by different tasks, so like we can get into that next, but like this is the exact performance while I actually take a look at what the time taken is.
Do we have a architecture, Raj, in the paper, or?
Like it's not described right here, but like I can give a quick overview, and like the whole thing is like open sourced, so we can go into like how it's actually being done. So maybe this is helpful if that's what you're looking for.
Yep. Actually, this exactly.
Oh,
So
okay, perfect.
the input is the bidirectional transformer encoder. Okay, so we're getting an input text. It goes through this encoder layer.
Yep.
And then we get a vector. Okay, and then it goes to this decoder, autoregressive decoder.
Yep. And then like the constraint, like this part is for like the multilingual variant of it. So in case we want only one language, you can just like hide away everything else apart from one language.
Yeah,
And
that's
then
fine.
take it to that, and then you have the predictions.
Sequence schools and schools. Okay.
And yeah, so it's pretty much like these two things, and like it uses a pre-trained like BART model, and then runs it through like all these extra like documents for in the training data, and then like that plus the try is used for like actually generating like the article names at the end of it.
So sorry, I'm going back to the same question, but just to clarify. So in the training set, we are having the Wikipedia titles, right? Only as part of the training set, and maybe no.
Not just that. You also have like the additional things with like context in which it's been used. So out here, it's just like have like a whole lot of text and then say that, hey, you have an entity out here called like Lekness Airport. And at the end of it, you say the answer that we care about is that Lekness Airport is what we care, but it points to an article that is also called like Lekness Airport, and like starts training the model that, yeah, this is what you need to look for.
And from where is this text context coming from? Say in case of Wikipedia.
So like you have a few cases. So one is you have like a lot of these data sets which are already present to identify like and disaggregate, sorry, I don't know how to pronounce that exactly, between entities. And that is one part. And you also train it on like the Wikipedia abstracts dataset in order to be able to like actually get the answers that you need.
So it's essentially a summary kind of, let's say, a page summary, in lack of better example. Could it be like a summary of the corresponding page?
I won't say summary. It's more like you'll use like the context in which the page is referenced instead, rather than like the page's summary itself. So you'll see that the like, for example, the like Wright brothers and like are referenced with like an article on like arc planes in the context of like the first flight. So you'll have a sentence in that fashion, and you have a link to like Wright brothers, and that's being what's fed into like what's being learned. Like, I'm not sure. Does that answer your question? Or
Uh, I mean, I'm not able. I mean, I see what you're explaining. I mean, that's pretty clear. But what is not actually, I'm not able to wrap my hand around is how am I going to set up my, let's say if I have to create this experiment, I have a knowledge base with a lot of articles in it.
yeah.
How would I start setting up this experiment? Do I need, from where would I get my context? I understand I'll have my titles, I'll have my links,
Yep.
references, cross titles. That's part of my knowledge base. But the other part of the input, which is getting entities and their context, how would I get that?
That would come in like two parts. So one is the knowledge base itself can serve as that, because the knowledge base should have like links between each other as a wiki. Then you can have like pointers from like one to the other. So that is one use case. The other, which would be more interesting, is like actual questions that might have come up, like Stack Overflow and things that are available internally, which might link you to like a wiki article with like all this information, or like what was the document storage setup. And that references is what like actually counts in this case. So you can use the two of those in combination. So if there are not enough links within it, you might need to look at like other sources. Like, I don't think.
And that's the challenge. I mean, this is, if you look it from Wikipedia and this setup point of this is already existing, but in a real, let's say, industry setup and a new use case kind of setup, generating or meeting all the prerequisites, it's pretty tough.
So yeah, that's like kind of what's being done from this graph to say like how often is a like entity being mentioned. So like if it's done like basically one time, you get like pretty reasonable accuracies if it's like an exact match. And like it improves as like the amount of like references increase. So if you have a really high number of things, you get like 90% accuracy when you're trying to retrieve it in all cases. Whereas it's harder if it's like only one. And if it's not, you don't have any cross references, then it's like only looking at, do you have this exact match? Then it's not as useful. And like other models would be like way more useful.
Okay. I mean, you can go ahead. Maybe I need to spend more time on this because it's interesting. I mean, this is a very practical problem in different industries where the people have knowledge bases. So this will be interesting to understand. But the place where again I'm still struggling is how to set up the experiment. Setup is not very clear to me.
Yeah, the setup is like, it's almost like generating something with like this setup effectively, where you'll need to have like the inputs and outputs defined, and like feeding, like it's one thing to like just generate this data, but to like actually have inputs for it is going to like, you'll need a good source for it. But that's like any machine learning model.
Yeah.
Can you go back to that JSON for a second?
Yeah. Oops. Okay. All right. Let me open it again. Yeah,
so
go ahead.
So can you just walk through the each of these values? Not the values, but the fields. So ID is what? What is ID? That's just a unique ID for that particular
More like just for that training entry.
Okay, so yeah, that's irrelevant. Okay, and then the input is
Like, the input's really long. It can have like any formatting and everything, but like this is effectively like the key part of the input in this case to say like this is the entity that we're talking about.
so that's coming from the body of some Wikipedia document.
Yep.
Okay, and then what's the next field?
So the next one is effectively what's being used. Say that what's the answer that we're looking for here, and what's the title.
So answer. So the entity is the answer. So what does provenance represent?
So provenance would be like what's the article ID and like other metadata. So out here, like the title is the same. So maybe if we take a look at something like, let's take this for example. Oh, don't tell me I forgot to check. Okay, like the title and answer are the same in this case. And like Wikipedia ID is like some extra metadata.
Okay, this is just additional data to reference inside of that wiki.
Yeah.
Yeah.
Okay, and then
I think it's like let's say you could have multiple Wikipedia pages or IDs, imagine, and multiple titles coming into for this particular entity we are looking for. So the provenance, I'm assuming, is looking at the structure is the list of all relevant or related Wikipedia IDs with their title.
Or like with the same article ID, because you can't have like one, like you, in this case, it assumes that you can only have like one article that's relevant in each case. So it doesn't let you do something more complex to say that, yeah, you have like 5 articles with this ID.
right, so that particular 1981 entity has been linked to this article, 1981 African Men's Handball Championship. And then the meta information it's using is whatever's to the left and right of that entity. And it goes some number of tokens on either side.
Like effectively pre-parsed, so you don't have to like do it separately.
Right.
But the provenance, Raj, will have only one, let's say, mention of an entity, like only one Wikipedia ID in it, along with its title.
Like more like this is in the case of like this in training data, but otherwise you can have like multiple references. So
yeah, and that's what it talked about, selecting top 3 article, isn't it? Is that related to this?
No, like that's a slightly different case. So
okay.
like in a single query, so this is the one with like Leonardo da Vinci. So to be able to take something like this and tag both like Leonardo and Mona Lisa independently is like the task at hand. So having like multiple options would be to say that you have Leonardo da Vinci, but you also have like Leonardo DiCaprio and other options. So that would be like the top 3, whereas
okay.
here it's like multiple like documents that have been linked in a single sentence. So yeah, you can just skip over like the previous one on constraint beam search. And yeah, so this goes into like how exactly the like entity linking component is done. So up to this point, we're only going over like you have text that is already like pre-labeled and you have to find a link for that. So this goes into like trying to generate stuff and like find what the tokens are. So given a piece of text, can you like auto tag it with like mentions? So then this section like goes into that part of it. And then goes into like 3 cases where like 3 settings in which the actual model at hand for genre is being checked out. So one is like the disaggregation case that we saw earlier. The second is the end-to-end linking case, in which case we have like a really long article without any links. And then you have to add links for every entity in there. And the third is like to retrieve a document given like a complete natural language query. So that would be the case where it's like the 3 Mile Island incident and details on that. And so it performs reasonably okay in the disaggregation case, but not as well as the other options. But its results start to look much more interesting in the other cases, where you're actually looking at like creating the link in the article and also adding a link to it. So it almost has like a 12% improvement over like other cases in this data set, 10% in other. So that is pretty fascinating. And the final one would be to say that, yeah, can you answer like a natural language query, in which case it kind of like blows all the other options out of the water.
Can you explain the terminology autoregressive and then end-to-end linking?
Yeah. So the autoregressive part is like effectively you would be referencing the data that's, or sorry, not data. How do I phrase it well? So an autoregressive thing would be something that takes and accounts for like the past with things that it's generated and has like a random process which generates the next entity that's present. So it knows that it's generated like Leonardo D, and then it has like options on like the word that it generates next. And then it can choose to generate like either Caprio or Vinci, or it needs to close like at that point, you don't have like any other options. So like it takes like it has memory of everything it's generated up to that point, and then chooses what to do next.
And it's always going left to right?
So that is the case with like autoregressive. And for the other case on like what exactly is being referenced by the end-to-end entity linking. So like this section kind of like describes what's being done. Like you have a document with like a bunch of tuples where like you have an entity and then you need to start tagging it. So yeah, one sec, let's take like a better example. Yeah, so one sec. Yeah, okay, like this is exactly what we need. So it has like this really long string, and then you have to predict like what spans exist and what spans actually have links to something else. So out here it goes and starts to link like different parts into like something links over to Spain, for example, Spanish. In other cases, Madrid would link over to the city, whereas in other cases, like you'll have like Real Madrid being actually linked to in the required place. So being able to output that would be like the main goal of like the end-to-end linking task.
So end-to-end linking is basically, the end-to-end part is just the entire input.
So it's more like you don't even have the start and end entity marks that we saw in the inputs earlier. So for example, out here, you don't have like this or this, and then you have to predict what thing is actually being tagged along with what needs to be linked over to.
Oh, so you have untagged information and you have to determine what are the entities and then where should those entities be linked to. Got it.
So for example, in the actual case with end-to-end linking, you might also have like Ivory Coast being linked to, African Championship might be separately linked, and 1981 might probably not be linked because it's harder to infer unless you have got through like the entire sentence. So that part might be something that varies. And so this is going to be measured against like what the expectations are and what might be predicted.
But it's only doing a single pass, right? You're not going back. Let's say in that 1981 example, you would not go back and narrow it down. You would just simply say these are the multiple options.
Not quite, because in this case, it would take the entire string as input, and only after that's done would it start generating the output. So it has context of like everything that is the input, and then figures out what the output should look like. So it can actually determine what a tag should be based on information that comes later.
Maybe a very silly question, but in the example, if you go back, we have this start entity and end entity marked. So that is kind of, we have already marked these things, or that's like, how do we say this is a start, this is end?
So for example, this is something that showed up on my history. So
Yeah.
let's take this. So for example, out here you have like Government of India, but
Yeah.
it also contains a URL link to the Wikipedia article for that.
Yeah. Yeah.
And then in this case, President of India, like the actual thing being mentioned differs from like what's actually showing up. So that would be like one case where there's some link that exists and like it has something that's actually being referenced. And
Okay.
the start and end entities would be like the start and end tags around Government of India.
Okay. Okay. Got it. Yes. Yes.
Point out to the article that's present.
Yeah. Yeah. Thanks.
Was this Wikipedia's entity labeling like was first like hand input by some people like writing the articles, or it was like auto-generated?
Like Wikipedia would have been manually entered and like
I see.
over like a really long time. But like this might be like useful for like knowledge bases to like start inferring extra links that might exist and start connecting it further. So it assumes that you have something already, but it starts to like build on top of it, but would come with some amount of noise. So it's almost like you need like manual approvals until you feel like we can trust it to do what's required.
Okay, I see.
This is really what you mentioned, Raj, is helpful. Let's say if we have a big knowledge base, which is not having enough references across, let's say, documents, this can, but few references, this can be used to establish that kind of linkage within the knowledge base as well.
Yeah. It's like one step at a time and then like iteratively improve on top of it.
Yeah, you validate it and then keep on. So in a way, let's say if you have a very loosely linked knowledge base, after this you can have a very tightly linked references would be pretty good.
Yep.
That sounds.
Yeah, so in the interest of time, I'm just going to skip over some of this bit. And there's like some stuff on like the application studies and then on cold starts. I'll quickly touch cold starts. The ablation study just talks about like how we might be able to remove like some of the inputs and how does it perform. Like spoiler alert, it doesn't perform as well, but yeah, like would need to gloss over that because cold start is kind of more interesting because cold start is like you have just provided it like 50 Wikipedia article titles that it has no idea about and has not seen before, and then start to say that, okay, tell me like and link me to it. So places where it did really well in this case was if there's like an exact match compared to that entity name, it knows well enough to be able to link to it. That worked in like 19 out of 50 cases. And in other cases, like it performed like at around 45%, which is like you don't have metadata available, but you still have a average quality prediction, which could be used to assist humans in like creating a link, which proves to be like really useful because someone creating a new article is going to have like a really large task of like creating links from everywhere else. And just being able to say that these are potential places for links could be a really valuable scenario. And this part of the thing almost leads to like what a next paper could be because there's nothing else doing this. So this might be a next challenge that they are proposing. And yeah, that is about it.
I just pulled up a bunch of articles on autoregressive models that I'm trying to understand. So I'm a little bit behind.
This is a great find, Raj.
Yeah.
Thank you.
Yeah. I see a
thank you.
lot of utility of this. At least, I mean, forget about everything. I said the point that you mentioned, Raj, about establishing the linkages, that itself will be very useful. I mean, I find it very useful. And
Like,
Ilya, to your point, autoregressive models are essentially, you can think of them like a time series, wherein, wherein imagine if you just look at some n days before and you try to predict the next n days. So let's say you see temperature last 5 days of temperature and you forecast to next 5 days of temperature.
Right.
So that's kind of autoregressive.
That makes sense.
And again, here it's pretty neat. I mean, all the sequence models are kind of autoregressive in nature.
Yeah.
This is really a good find. I mean, I definitely would love to go into depth of this paper.
Yep.
Thanks, Raj.
And
Really appreciate it.
Thank you. Thank you very much, Raj.
Thank
no
you.
worries. And yeah, hope you liked it.
Yeah, thank you.
Very much enjoyed it.
Any other questions to Raj before we close up? If no, then thanks everyone for coming. Thanks Raj for presenting. See you guys next week. Good luck with classes. Bye.
Bye.
folks.
See ya.
Bye bye.